Let's take a look at this problem. We want to find the derivative of y with respect to x of square root of xy is equal to 2. Now this square root of xy, I can rewrite that as xy to the 1/2 power. We never want radicals. There is a little bit of a shortcut here we could use. I'm not sure if it saves you a whole lot. I like this form a little bit better for a specific reason, which we'll talk about later. But you could split this up into x to the 1/2 times y to the 1/2, and then go from there. Now, we're going to use implicit differentiation, so we'll take derivative of everything where it's sitting. So we'll take the derivative of the xy to the 1/2 with respect to x, and we'll take the derivative of the 2 with respect to x. Now this is a chain rule, the general power rule. We got parentheses to a power. Our taking derivative of it, take a power, put it out in front. What's inside your parentheses remains as is. Lower your power by 1. So it becomes 1/2 minus 1 times the derivative of what's inside your parentheses. So again, take your power, put it out in front. What's inside your parentheses remains as is. Lower your power by 1 times the derivative of what's inside the parentheses. Now the derivative of 2 is 0. So we get 1/2 xy. 1/2 minus 1 is negative 1/2. And okay, I'll do it over inside here. This is product rule. This is P and this is Q. I still don't have room. It's poor planning. There we go. Okay, so we need P prime and Q prime. P prime, the derivative of x is 1. Q prime, the derivative of y is 1. But since we're taking the derivative with respect to x and it's really y, we have to put on a y prime. And our formula says P prime Q plus P Q prime. So we're going to have 1/2 xy. 1/2 minus 1 is negative 1/2 times P prime, which is 1, times Q, which is y, plus P, which is x, times Q prime, which is y prime, is equal to 0. Well, we don't want negative exponents, so I'm going to take this down to the denominator. So we got 1 over 2xy to the positive 1/2. Remember, you take anything opposite in a fraction, sign changes. 1 times y is y, plus xy prime is equal to 0. Now we need to solve for y prime. And there's shortcuts to this that definitely save you time. I'm going to ignore those shortcuts. I'm going to our five steps we looked at in class for solving for y prime. First step was to get rid of parentheses, or get rid of brackets, as the case may be. So I'm going to take this fraction here and I'll multiply it times the y and times the x y prime. That's going to give me this y over 2xy to the 1/2 plus x y prime over 2 times xy to the 1/2 equals 0. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. These denominators are the same, so I can multiply everything by 2xy to the 1/2. So I'll multiply times this first fraction. And I'll multiply times this second fraction. And we'll multiply times the 0. Well, the 2xy to the 1/2 cancels that 2x to y 1/2. This 2xy to the 1/2 cancels that 2xy to the 1/2. And we're left with y plus x y prime. And 0 times anything is 0. Shortcut on this one, you could have multiplied both sides by that right up here at this step, and very quickly got there. But again, I'm going through my 5 steps for solving for y prime we looked at in class. Our third step is get everything with y prime on one side, everything else on the other side. So I'll take the y, move it over to the right side. So we get x, y prime is equal to negative y. Fourth step, if y prime is in 2 or more pieces, 2 or more terms, 2 or more whatevers, factor it out. It's only in one term. So step 5, divide both sides by what's in front of / back of y prime. There's an x in front of it, so I'll divide both sides by x. And we get y prime is equal to negative y over x. And that's our answer. This problem, usually radicals are really hideous, and normally this would cause us nightmares. Not that this one was trivial, but the reason why it worked out fairly nice is because there was 0 on the right side after we took the derivative.